that is why we have a huge energy crisis these days. It is one of the major reasons for this. And if you can see that most of the utility providers, they have resorted, almost all of them, they have resorted to automatic meter reading. But this also does not resolve the issue of meter bypassing, because meter is going to read only that energy which a certain consumer has used. But if you directly hook a wire onto the distribution line, then you cannot just charge them for that particular electricity that is used, because they don't know who is using that electricity. Because it is a you directly hook a wire onto the distribution line and take it to your house. Nobody knows who's using that electricity unless somebody from the utility provider comes and they have a look and they say, okay, this is the line going to somebody's house and we have to remove this. So this is what's happening there. And in India, I was reading a case study in India, and you will be surprised to know that they have about more than 80 ways of, they have invented more than 80 ways of stealing electricity. And one of those ways was very interesting. It was, what they used to do was that in certain places where there is a very high power transformer, what they used to do was, in their house, they used to wind another transformer. And as you know that, there is a magnetic field around, wherever there is a transformer, it has a certain magnetic field around it. And if you place any conductor in a magnetic field, depending upon the strength of the magnetic field, there is electrostatic induction, and a current is going to flow in that conductor. So what they used to do was, they used to wind up another transformer inside their house, near another transformer. Nobody would notice, because if it's inside their house, nobody can see it like that unless they go inside the house and check it. So because of the magnetic field around that transformer, there used to be electrostatic induction. They used to wind up a step-up transformer and then wirelessly steal electricity. So, this is a very innovative way of stealing electricity, and it cannot be detected very easily.
Very worth
so,
it.
There are different ways of doing these things. So, so what's the role of communication in a smart grid? First of all, just like I said, smart meters are one of the key components, and the advanced metering infrastructure is one of the key components that has to be there in a smart grid. Because of the smart meter, the consumer's energy consumption habits and their energy utilization and all the statistics can be directly conveyed to the utility provider, and you can eliminate the need for manual meter readers. And also, the communication system should cover the entire smart grid, because in a certain area, if you have a certain utility provider who covers maybe an entire city, so you have to have an appropriate communication infrastructure in place that spans the whole of the smart grid. So it has to span the complete city, and as you know, depending upon the size of the city and the number of consumers, it is not a very easy job to integrate everything, and the communication that takes place, it is not very easy. I will come to the issues, and then you will know what are the main issues in this particular case. This is just an example architecture. Now, if you have different smart meters installed in a certain residential area, this is just one of the scenarios how you can implement, the advanced metering infrastructure. The smart meter can have multiple interfaces. For example, it can have a ZigBee interface, and it can have either GSM Edge or WiMAX LTE, whatever. So one of the interface is for a shorter range wireless connectivity, and one of the interfaces for a backhaul connectivity. So in this particular case, what can happen is that, let's suppose we have current transformers installed at certain points on the distribution line. So what happens is that the current transformers, they can measure the electricity at two different points, and if somebody tries to hook a wire, there is going to be a difference in the readings. So that, then you can implement different state estimation algorithms to determine that whether actually it is an instant of electricity stealing, or it is just, there is a bit of fluctuation or something like that. So there is a EU project, I don't exactly remember the name, but the whole EU project is based on implementing state estimation algorithms for this particular case, in order to reduce the possibility of false alarms and accurately detect the instances of meter bypassing. So in this particular case, you can see that the smart meters, they can transmit their information to the current transformers, and then based on the information provided by the smart meters and whatever they read at a particular point on the distribution line, they can compare that reading, and then if they detect that something is going wrong, then they can transmit that information to a data aggregator or concentrator module, and then it can directly inform the electricity utility provider, and it can also send them, since these modules are not mobile, once you implement them, they are going to be static. So you can also send their coordinates as well to the electricity service provider, and they can also come to know about the location of this particular problem. So in this case, the smart meters, there are already many companies who are manufacturing smart meters with both of these interfaces, Zigbee interface, and either it has a GPRS interface or an edge interface. So already we have these kind of smart meters in the market. And then this is another architecture in which we only have Zigbee modules installed in the smart meters. I'll come to the advantages and disadvantages of including only one interface and then two interfaces in these smart meters. There are advantages and disadvantages of all these implementation. Now in this particular case, the data from the smart meters is communicated to the current transformers and comparator modules, and also via the Zigbee module, that information is transmitted to the data concentrator module, and each smart meter has its own ID, and it might have a unique ID for each consumer and everything. So based on that particular ID, it collects the information and then it sends it to a regional data center where the data is collected by the utility provider. And this is the third scenario. In this, we have another kind of technology, that is data communication via power lines. Now this is actually a very active research area these days. It is also known as power line carrier communications, PLCC. It is a very active area of research, and basically there are a lot of devices. One of a very popular device that is in the market is known as HomePlug, and you just have to it is a certain modem, power line modem. You just have to install it in a power socket, and it has an Ethernet interface, and you can just use another modem and plug it somewhere else in the house, and it also has an Ethernet interface. So when you connect your PC or your laptop with it, you can connect to another system which is connected to the other socket in your house. So you can connect two systems, and the communication takes place using the power cables that are there in your house. So the data rates are not very high, but they are still in megabits per second, multiple megabits per second. So it's quite good enough. But in order to use these power line modems, power line communication modems, or you can call them PLC modems, on the distribution lines, it is not a very easy job, because the communication can only take place towards a certain transformer, and you cannot communicate through a transformer to another PLC module, because the transformer is either going to be a step-up transformer or step-down transformer, and because of that, you cannot just simply communicate data through a transformer. But if we implement a certain data concentrator module near a certain transformer, then at least we can use the power line communication modules to transmit that data to that particular data aggregator module, and then the data aggregator or concentrator module can send the data to the regional control center via different backhaul technologies. Now, a very big issue here is that if you install let's suppose GPRS modules or edge modules or HSTPA modules in a smart meter, now in a GPRS module or any of these modules which connect you to a certain base station in a cellular network, you have to insert a SIM card in these modules. If you check if you Google these GPRS modules, you will get a lot of companies, and if you check their data sheets, you have to insert a SIM card, a valid SIM card that is provided by a certain service provider. You have to insert a SIM card in that module in order to enable it to connect into the nearby base station. Now, whenever you insert a SIM card in a GPRS module or in an LTE module, it acts similarly like a user to that particular network, because the network has to allocate a certain